Welcome to the Copperfield Electric Podcast.
Glad to be here.
Right now, hiding behind the drywall of your pristine garage, a 50-year-old metal box is basically having a panic attack.
Oh, yeah. Probably as we speak.
Right. I mean, we spend so much time obsessing over the visible parts of our homes, the Italian marble countertops, the bespoke paint colors,
Yeah.
the hand-scraped hardwood floors.
Fun stuff.
Exactly.
Yeah.
But we completely ignore the central nervous system of the house.
Yeah.
The electrical panel. It just sits there in a dusty closet doing its job for decades, completely invisible to us, until, the very second we plug in a shiny new electric vehicle charger in the driveway.
Boom!
Right? Suddenly we realize our home's aging infrastructure is on the verge of total collapse. So today we are taking a deep dive into the absolute beating heart of residential and commercial electrical systems.
It's a great topic.
Yeah, we're trying to figure out how long it actually takes to rip out and replace that vital piece of hardware. And we're using two main sources for this. The official service profile of Copperfield Electric and a really detailed article by Renee Hernandez called How Long Does a Typical Panel Upgrade Take?
Yeah, that article really breaks it down well because, when you look at the engineering behind this, we are expecting our homes to accommodate 21st century high-draw technology on mid-20th century hardware.
Right.
And the math simply does not compute. Upgrading a panel is not a luxury renovation. It is a critical life safety intervention.
Life safety, that's a strong way to put it, but it's true.
It is. And when you're dealing with life safety infrastructure, you need a very specific type of operational footprint. Look at Copperfield Electric, for example.
Okay.
The reason they maintain this massive coverage grid across Southern California, so we're talking Orange County, Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Tustin, all of it.
Wow, that's a huge area.
It is, and they offer 24-hour emergency response across that whole grid because when a panel fails, it's an immediate crisis. It is not a call us on Monday kind of inconvenience. I mean, they handle everything from wiring brand new ADUs, accessory dwelling units, to high voltage power distribution for commercial elevators.
That's quite a range.
Yeah, well, electrical demands are universally scaling up, so they have to.
So let's dig into the timeline of an upgrade. Because fast is a highly subjective term in the construction world.
Whoa, absolutely.
Like when someone tells me they are going to rip out the central nervous system of my house, my immediate thought is simply, how long am I going to be sitting in the dark?
Right. Where are my flashlights?
Exactly. And according to the Hernandez article, if we look at the standard physical swap of a panel, we're staring down a 4 to 8 hour total power outage.
Yeah. 4 to 8 hours of highly orchestrated, hands-on physical labor where the home is entirely dead. And the first phase alone, the utility disconnect, eats up 1 to 2 hours before a single wire inside the house is even touched.
Wait, really? 1 to 2 hours? I would imagine the electrician just, walks up to the box, flips the main breaker switch to the off position, and just starts taking things apart. Why does shutting off the power take 2 hours?
Well, because flipping the main breaker only kills the power flowing into the subcircuits of your house.
Okay.
The massive service lines coming into that main breaker from the street, those are still incredibly live. They are always hot, pulling unmetered, raw electricity directly from the grid.
Oh, wow. I never thought about that.
Yeah, so no electrician can safely touch the inside of that panel while those mains are hot. The utility company actually has to dispatch a technician to physically sever the connection outside your home.
Up by the street?
Usually up at the service drop on the roof or sometimes right at the meter. And until that external lifeline is cut, it is a massive safety hazard.
Okay, so the lifeline is cut, the house goes quiet. I assume the next step is pulling the old box out of the wall, like grabbing a crowbar and just getting to work.
No. Calling it demolition is giving it the wrong visual entirely. Yeah, think of it more like surgery. The removal phase takes another hour or two, because the electrician has to carefully document and disconnect each individual circuit.
Oh, right.
I mean, if you've ever seen the inside of a panel, it looks like a bowl of multicolored spaghetti.
It really does.
Yeah.
Just a rat's nest.
Exactly. And they have to trace every single wire and take meticulous notes on what circuit it belongs to. Because, well, if the previous homeowner was a DIY enthusiast who left, like you said, a rat's nest of tangled wires behind, safely extricating that old panel without damaging the existing infrastructure is a really painstaking process.
Right, because you don't want to rip the wires out of the walls.
Exactly.
So we are potentially 4 hours deep into this project, and all we have to show for it is a hole in the wall and a bunch of dangling copper wires.
Pretty much.
So let's talk about putting the new box in. You have the notes, you have the wires. It sounds like putting pegs into a pegboard at this point. Why does the installation phase take an additional 3 to 4 hours?
Well, physics and thermodynamics dictate the speed here.
Thermodynamics.
Yeah. Every single connection inside that new panel has to be torqued to a highly specific manufacturer-dictated metric.
Yeah.
This is entirely about preventing house fires.
Okay, you have my attention. How does that work?
Well, when electricity flows through a wire, it naturally generates heat. When the metal in that wire heats up, it expands. Then when you turn the appliance off and the wire cools down, it contracts.
So it's like a constant microscopic expanding and shrinking inside the wall.
Continuously, every single day. So if a wire is screwed into a breaker even a fraction too loosely, that daily expansion and contraction will eventually cause the wire to wiggle free.
Oh, geez.
Right. And when a live wire wiggles loose but is still near the terminal, the electrical current literally tries to jump through the air to bridge the gap.
To make the connection anyway.
Exactly. That is called an arc flash. Arcing creates intense sparks, and sparks inside a dusty wall cavity
Create catastrophic fires.
You got it. But on the other end of the spectrum, if the electrician over-tightens the screw, they can crush and deform the copper wire.
Oh, so you can't just crank it down as hard as you can.
No, because crushed copper increases electrical resistance, which creates massive amounts of dangerous heat.
Right.
So the electrician is actually using a calibrated torque screwdriver to tighten dozens of tiny connections to the exact inch-pound of pressure.
Wow.
You cannot rush that kind of precision.
That completely reframes the process for me. I never thought about thermal expansion causing a wire to wiggle free. I just figured you tighten it like a jar of peanut butter and walk away.
A lot of DIRs think that, unfortunately.
Yeah. So after all that precise torquing,
Yeah.
we are in the final stretch, right?
Yeah, the final hour is dedicated to testing and labeling. The utility company comes back to restore the power from the street.
Okay.
Then the electrician tests every single circuit under load to ensure the breakers trip the way they are designed to. And finally, they build a highly accurate new panel directory.
Well, that's nice.
Yeah, instead of a faded, scribbled note from like 1985 that vaguely says plugs, you have a pristine label detailing exactly which breaker controls the guest room outlets and which one controls the kitchen island.
Honestly, just having an accurate label is a massive quality of life upgrade on its own.
It really is.
But the messy reality of these upgrades is that this 4 to 8 hour timeline is the absolute ideal baseline.
Oh, yeah. The best case scenario.
Right. Because when you look at older neighborhoods, a few major wildcards jump out that force that timeline to stretch significantly. Like, let's talk about the jump from 100 amps to 200 amps.
Oh, yeah.
Because that is essentially a requirement now if you want a company like Copperfield to install a level 2 EV charger in your garage.
Yeah, the math completely changes when you increase the amperage. Swapping an old 100-amp panel for a new 100-amp panel fits nicely into that 4 to 8 hour window.
Yeah.
But pushing the service up to 200 amps, that turns it into a 10 to 12 hour grueling physical endeavor.
My brain immediately goes to an automotive analogy here. Upgrading to 200 amps in an older house feels like trying to drop a massive V8 engine into a golf cart.
That's a great way to look at it.
Right. You can't just swap the engine and expect the golf cart to handle the raw power. You have to rebuild the entire chassis to support it.
Yeah.
But actually, let's back up for a second. What exactly is an amp, and why does an EV charger or modern heat pump demand so many of them?
Okay, so think of electricity like water flowing through your home's plumbing.
Okay.
Voltage is the water pressure pushing through the pipe. Amperage is the actual volume of water flowing through that pipe at any given moment.
Gotcha. Pressure versus volume.
Right. So a standard refrigerator uses a very small volume of water. An EV charger is basically asking for a high-pressure fire hose of water. And your old 1970s house, it was built with the electrical equivalent of garden hoses.
Oh, so pulling more volume means the pipes, meaning the main service wires coming in the side of your house from the street, have to physically be wider to handle the flow without bursting.
Exactly. The infrastructure outside the house has to be completely bulked up. The electrician has to rip out the old meter socket, install a much larger one, and run brand new heavy gauge service entrance cables.
And I imagine thicker wire is harder to work with.
It is incredibly heavy, stiff, and notoriously difficult to bend and wrestle into place. It adds hours of heavy lifting to the project.
I would imagine finding older wiring types buried inside the walls is an even bigger nightmare.
Oh.
Aluminum wiring, for instance.
All aluminum?
I know it was heavily used decades ago because it was cheaper than copper, but why do electricians dread finding it during a panel swap?
Well, the chemical properties of aluminum make it a massive liability in modern systems.
Why is that?
So when copper oxidizes, it turns green, right? Like the Statue of Liberty.
Right.
But it still conducts electricity perfectly fine even when it's green. When aluminum oxidizes, it forms a white, powdery rust.
Right.
And the aluminum oxide actually acts as an insulator. It resists the flow of electricity.
Oh, and resistance causes heat?
Exactly. As we established earlier, electrical resistance creates severe heat. Add that to the fact that aluminum expands and contracts much more drastically than copper under a thermal load.
Oh, man.
So you have oxidizing wires violently wiggling loose and sparking inside your walls.
That is terrifying. What about knob and tube wiring? Just hearing the phrase sounds like steampunk technology.
It is terrifying in a modern context. So knob and tube uses actual porcelain knobs to hold individual wires apart inside the wall cavity.
Porcelain. Wow.
Yeah. But the critical flaw is that it has no grounding wire.
No ground at all.
None. And a ground wire is an emergency escape route for rogue electricity. So without a ground, if a rat or a squirrel chews through the degrading cloth insulation of a knob and tube wire in your attic, the entire metal chassis of whatever appliance you plug into that circuit could become electrified.
Jeez, so you touch your toaster, you get zapped.
Exactly. So an electrician cannot legally or ethically just slap a modern, highly sensitive arc fault breaker onto a degraded, ungrounded knob and tube circuit.
So they would have to tear open the walls to fix it.
Yeah, they have to at least partially rewire the home to meet modern safety codes. So the moment they discover aluminum, or knob and tube, that one-day panel swap transforms into a multi-day invasive reconstruction project.
And then you have the basic geography of the home playing a role too, right?
Oh, definitely.
Like if your electrical panel is mounted on a wide-open expanse of drywall in a clean garage, the electrician has a full range of motion. But if that panel is wedged behind a 50-gallon water heater.
Or buried inside a tiny hallway closet stuffed with winter coats.
Right. Every single movement is restricted.
Yeah, contorting your body to get a calibrated torque screwdriver perfectly aligned inside a cramped metal box is exhausting. A straightforward 4-hour task easily becomes a 6-hour struggle simply because of a lack of elbow room.
So if we step back and look at the big picture here, we've been focusing intensely on the physical labor of the installation day.
Right.
4 to 8 hours. But the reality is, the physical work is just one isolated event. Upgrading a panel is actually a massive 1 to 3 week administrative journey.
Yeah, and the invisible timeline is usually where homeowners experience the most friction simply because they do not understand the behind-the-scenes coordination.
The waiting game.
Exactly. Professional outfits handle this logistics puzzle daily, but for a homeowner, the waiting game is the hardest part. The administrative journey starts long before anyone touches a tool. Permitting alone adds 3 to 10 days right out of the gate.
So you cannot just quietly rip out a panel on a Tuesday.
Nope. The city demands an approved permit before a licensed electrician can even legally request the utility company to disconnect the power.
So we wait for the city to say yes. Then we wait for the utility company. And the article mentions that utility scheduling seems to be the single biggest bottleneck in the entire operation.
Because they run on their own municipal calendar, not your contractor schedule. The utility company has to dispatch a crew to cut the power and then dispatch them again later that day to reconnect it. Getting on their calendar can take anywhere from a few days to 2 full weeks.
This feels like a massive vulnerability in the process. I could hire a premium team like Copperfield Electric. They have background check pros ready to roll. They have the equipment. They're fully staffed. And you are telling me a sudden heat wave could completely derail my EV charger project.
Oh, absolutely. A heat wave, a severe thunderstorm, high winds, any of these will immediately scrap your schedule.
Why?
Because during extreme weather, neighborhood transformers blow out, trees take down residential power lines. The utility companies immediately pull all their crews off of scheduled elective residential disconnects and send them out to do emergency grid triage.
Okay, that makes sense.
Right. They are morally and legally obligated to prioritize restoring power to a dark neighborhood or a medical facility over disconnecting the power for your planned home improvement project. Your local electrician is entirely at the mercy of the grid dispatchers.
When you frame it around emergency triage, it makes complete sense. They are managing citywide crises.
Exactly.
And what about if your home has underground service rather than those standard overhead wires swooping down from a telephone pole? Does that complicate the utility visit?
Underground service adds massive logistical hurdles.
Really?
Yeah, because an overhead wire is visible and easily accessible via a bucket truck. But underground service might require actual trenching to lay thicker cables.
Oh, right, for the 200-amp upgrade.
Yes, and you cannot just start digging a trench in a residential yard. You have to call specialized municipal locators to come out and spray paint the grass to mark existing gas lines, water mains, and fiber optic cables.
Yeah, you see those red and yellow lines all over the grass sometimes.
Exactly. Digging blind is illegal and incredibly dangerous, so coordinating underground utility crews and location services adds layers and layers of complexity to the calendar.
Okay, so eventually the utility disconnects the power, the electrician executes their perfectly torqued, beautiful installation, and the utility reconnects the grid. We have power again. But the project still isn't technically over, is it?
No, it's not. The final administrative hurdle is the municipal inspection.
Oh, right. The city has to check the work.
Yeah, this usually happens a few days to a week after the physical installation. A city inspector comes to your home for a rigorous code compliance check. They verify that the grounding system is flawless, that the breaker sizes perfectly match the wire gauges, and that the panel directory is accurate.
And if they find an issue?
The electrician has to fix it, and they inspect again. Only after the inspector signs off and passes the panel is the project legally closed out.
It really is a bureaucratic marathon. So knowing that we as homeowners are completely at the mercy of the city permit office, the weather, and the utility grid triage, how do we survive the actual installation day?
Preparation is key.
I am picturing my own garage right now, and the electrical panel is currently blocked by a mountain of moving boxes and a broken bicycle.
Well, the most immediate, actionable step you can take is clearing that physical space. You need to provide at least 3 feet of unobstructed clearance around that panel before the crew arrives.
Okay, so move the boxes.
Yeah, and it is not just about being polite. It is a strict Occupational Safety and Health Administration and National Electrical Code requirement.
Oh, I assume that ties back to the arcing and the live wires we discussed earlier.
Precisely. Electricians need an unobstructed escape route. If something unexpectedly flashes or sparks while they are testing a live circuit, they need room to physically jump backward.
Wow, okay.
If your panel is barricaded by heavy boxes and a bicycle, they legally and safely cannot start the job. You will pay for a delay that was entirely avoidable.
Okay, so move the boxes. That is step 1. There is another concept here in the source material that I absolutely love, treating the installation day like a planned practice run for a real power outage. It is essentially a fire drill for modern life.
I highly recommend doing this. Your house is going to be completely dead for up to 12 hours. It is the perfect modern stress test. You have to charge your laptops and phones the night before.
Right.
You have to figure out how to keep the refrigerator and freezer doors securely shut all day to protect your food supply.
Finding out exactly how long your family can survive without Wi-Fi, without the television, and without the ability to just microwave a quick snack.
Exactly. And think about the weather. If the upgrade is happening on a sweltering July afternoon, how are you keeping your kids and pets cool without central air conditioning?
Yeah, that could be miserable.
So having a solid plan, maybe that is the day you take the family to an air-conditioned movie theater or visit relatives, makes the entire experience infinitely less chaotic.
Beyond surviving the day, there's a huge financial aspect to this planning as well. If we are opening up the walls and dealing with the utility company anyway, how do we optimize the money we are spending?
The smartest financial move a homeowner can make is planning for the future during the initial assessment.
Tell me more about that.
So if you know you are going to want a sub-panel for a backyard workshop in 2 years, or you are planning to add central air conditioning next summer, tell the electrician today.
Oh, I see. Paying an electrician for an extra hour of labor today to pre-wire for next year's hot tub seems incredibly smart.
It saves you a fortune. They can combine the work, size the new panel aggressively to handle the future load, and pre-wire those heavy circuits right now.
That makes total sense.
Yeah, it saves you from having to endure a second power outage, but more importantly, it saves you from paying for a whole new municipal permit, a second utility truck roll fee, and a second city inspection fee down the road.
Do it once, cry once. Upgrading an electrical panel is clearly not a quick afternoon handyman chore. It is a beast of logistical, 1 to 3 week administrative project wrapped around a highly technical, high-stakes physical swap.
Which is exactly why finding an established contractor who knows how to navigate that unseen timeline is paramount.
Yeah.
A company like Copperfield Electric provides realistic estimates up front so homeowners are not caught off guard by the bureaucracy. Folks anywhere in Southern California can reach them directly to get that initial assessment started.
And what are those numbers again?
Their dispatch numbers are 626-622-9694 or 949-806-3169, and they can map out exactly what your specific timeline and amperage needs look like.
That's 626-622-9694 or 949-806-3169. Because the reality is we are electrifying our entire existence.
We really are.
We are adding smart technology to every single room, plugging massive vehicle batteries into our garages, and installing electric heat pumps to warm our homes. We cannot continue trying to run a high-tech lifestyle on low-tech, aging infrastructure.
No, we can't. The sheer electrical demand we put on our homes today would be completely unrecognizable to the professionals who wired them 40 years ago.
Which leaves us with a truly fascinating thought to chew on as we wrap up this deep dive. We've spent this entire time talking about the struggle, the physics, and the necessity of upgrading our homes to 200 amps just to handle today's modern technology. But as our cars, our heating systems, and our daily lives become 100% electrified in the coming years, it makes you wonder, will 200 amps even be enough in a decade? Or will the homes of the future require commercial-grade power just to run a standard Tuesday?